In this video, we're going to be talking about acids, and I will give you a brief definition on what an acid is, how to identify an acid, and then the rest of the video is going to focus on how to name acids. So an acid is a compound in which one or more hydrogen ions are bonded to a negative ion. How do we identify an acid? Well, it's going to have acid in the name. So if I give you the name of something and it says acid in the name, it's an acid. Makes it pretty obvious for us. The chemical formula, a little bit less obvious, but still gives us a lot of hints. If the chemical formula starts with H, then it's probably an acid. There are exceptions to this. One notable exception is going to be H2O. We all know that that is water, and we are not aliens. We don't drink acid for hydration. H2O is not an acid. But for the most part, if something starts with H, it's usually an acid. So for the purpose of this class, if something starts with H, if a chemical formula starts with H and it is not H2O, then we'll just say it's an acid unless I tell you otherwise. Next, the name of an acid is based on the name of the negative ion that is part of the acid. And that will make more sense as we start going through the different examples of the rules for naming acids. So let's go ahead and scroll down to that. So our first set of rules, our first rule is acids that do not contain a polyatomic ion. So in this case, we are going to have hydrogen bonded to something that is a halogen, that is in group 7 on the periodic table. That's a column right next to the noble gases. So a hydrogen bonded to a halogen. And so our halogens, if you don't remember, we have fluorine, we have, I don't know the order, but we have bromine, we have iodine, we have chlorine, etc. So hydrogen bonded to any of these, and we're going to use this naming system. Hydroblankic acid, where the anion, if you don't remember, is an ion that has a negative charge. The anion that is attached to the hydrogen without its suffix is what is going to go in this blank. So the anion, which could be fluorine, chlorine, bromine, iodine, etc., is what's without the ending is going to go in the blank. So let's do an example here. We have HCl. Let's see what this looks like. What we are going to do, we're going to take the anion and cancel the ending and put everything else in the blank. So here we're going to get hydrochloric acid. So take the anion, cancel the ending, and put everything else in the blank. So cancel that IDE ending. Let's try another one. So that was our answer, hydrochloric acid. Let's try another one. What if we have HF? How would we do that one? Well, we have F, we identify that as fluorine or fluoride, since the F will have a negative charge, since it's bonded to a positively charged hydrogen. Anyway, it's fluoride, doesn't matter because we're canceling that ending anyway. Cancel the ending, and everything else is going to go in the blank. So we'll put hydro, fluor, spelt that wrong, fluoric acid. Hydrofluoric acid is HF. So it's going to be the same case for all of those other halogens that might bind with hydrogen. Cancel the ending and put that ending in the blank. All right, let's try our next naming rules. Next, what if we have an acid that does contain a polyatomic ion? Then what do we do? Well, first, we're going to look and say, sometimes our polyatomic ions end in ATE. Other times, they end in ITE. And we have a different set of rules for each of those types of polyatomic ions. We're going to first cover the ones that end in ATE. So for acids that contain a polyatomic ion that ends in ATE, we are just going to use this simple naming formula, blank ic acid. So same thing as before, the name of what is bound to the hydrogen minus the ending is going to go in the blank. So the name of the polyatomic ion with its ate suffix canceled is what's going to go in the blank. So our example that we're going to do here is H2CO3. H2CO3. So let's first identify what CO3 is. CO3 is carbonate. Specifically, it's CO3 with a -2 charge. That -2 charge, side note, that -2 charge is the reason that we have 2 hydrogens here instead of just 1 here. Just like when we were dealing with ionic bonds, we need to balance those charges out to 0 because there is no charge written here. So since hydrogen has a +1 charge and carbonate has a -2 charge, I need 2 +1 charges in order to balance out a -2 charge to 0. So just a quick side note, that's why it's H2CO3, not HCO3. So CO3 we identified is carbonate. So we are going to do the same thing as before, cancel the ending, and put everything else in the blank. So this is going to be carbonic acid. We canceled the ending and put everything else in the blank. The only difference between this and the previous rules is that we are not going to use the hydro prefix anymore. The hydro prefix is only for a hydrogen bonded to something that is not a polyatomic ion, for acids that don't involve a polyatomic ion. When they do involve a polyatomic ion, we don't use the hydro prefix. All right, so carbonic acid is H2CO3. Let's try one more example, and feel free to pause the video as you try to solve this on your own. So let's try HNO3. So you're first going to identify what NO3 is, and then follow those rules that we just set. All right, hopefully we were able to solve that. And we identify, so let's start this. We identify NO3 is nitrate. So it has that ATE ending. So we're going to use this naming system. Cancel the ending and put everything else in the blank. So we will end up getting NITR, nitric acid. So HNO3 is nitric acid. So anytime you end in ATE, you're just going to be, it's blank ic acid, where what goes in the blank is the polyatomic ion minus its ending. All right, let's move on to our final naming rule, where we have polyatomic ions that end in "ite." So if you look at your list of polyatomic ions that you have, some of them end in "ate", some of them end in "ite". Now here's how we name polyatomic ions that end in "ite". Here, instead of ic acid, when the polyatomic ion ends in "ite", it's going to be us acid. So blank us acid. So let's try an example. HNO2. NO2 is nitrite. So we are going to do the same thing we've been doing. Cancel the ending and put everything else in the blank. So we get NITR, nitrous acid. Because we canceled the ending, put everything else in the blank. Nitrous acid is HNO2. All right. And I was nice. I didn't make us memorize, at least for my class that I teach, I did not make us memorize a million different polyatomic ions. This actually ends up being the only example that uses this naming rule from the polyatomic ions that I gave us. That isn't an exception. So we're going to know that HNO2 is nitrous acid because it follows this rule. And this is the rules that we're going to apply when we take higher levels of chemistry. And we'll just know this and apply it when necessary. We were given some other polyatomic ions that kind of use these rules, but they have some exceptions. And and the last thing I'm going to do here is go through these exceptions. So here we have some acids. We have phosphoric acid, phosphorus acid, sulfuric acid, and sulfurous acid. And we're going to talk about how these are very similar to the naming rules. They do abide by the naming rules, but they just add a couple of letters that make them a little bit different and make them exceptions. So I guess maybe phosphoric acid sounds better than phosphic acid, and that's why this exception exists. I'm not really sure. Or maybe scientists just want to make things more confusing for us. But we're gonna remember it and we're gonna be fine. So H3PO4, let's identify what the polyatomic ion is. We have PO4. So PO4 with a -3 charge is phosphate. Let's just go through all these. PO3 with a -3 charge is phosphite. SO4 with a -2 charge is sulfate. And SO3 with a -2 charge is sulfite. All right, so if you notice, the same naming rules pretty much apply here. We cancel the ending. I'll do it in a different color. We cancel the ending and put everything else in the blank, where the blank is all the way up here. Put everything else in the blank. Where we would have had phosphic acid. But the exception comes in that we're going to add 2 letters. We're going to add OR before the ic ending. And that's why it's an exception. So that's all it is. We are just going to add 2 letters and then apply the same rules as before. So you can approach these exceptions in 2 ways. You can just say, hey, they are exceptions because I'm going to add 2 letters before the ending. I'm going to add 2 letters before the ending. Do that for all of these 4 examples. Or you can just say, I don't care to know why that they are exceptions. I'm just going to memorize these as is because they are the only exceptions that we're going through. So you can just say H3PO4, I'm just going to memorize that is phosphoric acid. And H3PO3, I'm just going to memorize that is phosphorus acid, etc. So if you want to just memorize these as is and make flashcards for these, that's fine. But if you want to just memorize that they are exceptions because they have 2 extra letters inserted and we're going to otherwise follow the same rules, you can do that as well. But that is all we have for naming acids. So hopefully that was helpful. Now we know how to name any acid that is thrown at us. Hopefully not literally, so we don't get chemical burn. But hopefully that's helpful.